Ladies and gentlemen, good morning, and welcome to the second day of the EU Raw Materials International Clustering event, and very warm welcome also to those that are following us online. This is the second day, so I should also say welcome back to those of you that were with us yesterday. Yesterday was a fantastic event where we had the chance to see a little bit of the policy outlook, what is cooking in the pot of the European Commission for European funding in terms of raw materials, of course. But most importantly, we saw the presentation of over 20 European funded projects and initiatives on raw material exploration, technologies. Really fantastic day to see what the projects are doing in terms of activities, in terms of the challenges they're having, and also in particular in terms of the results, the achievements they're getting. So if yesterday was a kind of a day about the past and the present, we want today to be very much a day about the present, but also the future. Today is a very important day to start preparing ideas and proposals for future projects. Before I go any further, I just want to give a quick thank you to the three projects that are supporting us for this two-day event. So S3 MudTrace and TerraVision, and the event is organized, of course, by us, the Iberian Sustainable Mining Cluster. So as I said, yesterday we had a little bit of a listening, networking. I heard that there was a very good interactions about all the participants. But today we want it to be about the present and also very much about the future. Yesterday was about sitting and listening, learning, understanding. Today is your day to have an active contribution, to really have meaningful conversations and start discussing about project ideas. Today we have three main sessions. We will have first a quick fire round of presentations from companies and organizations. They want to present their ideas, their business proposals. They want to present their challenges, looking for solutions. It will be a very quick fire round, as I said, because they will be given only 5 to 8 minutes to present this. So you will have to listen very carefully, pick up what you think are the most important points for you, and then maybe discuss them separately. In fact, the second session is going to be an innovation gallery. We'll have posters, we'll have a chance to interact in a relaxed way over a coffee to start pulling out the ideas and the discussions that we want to put in future projects. There will be some posters here, and there will be the coffee served upstairs. So we'll have about half an hour, 40 minutes to start mingling, but mingling with an objective, mingling with an idea, a network that will really start to be productive. The third and final session will be the matchmaking session, and this is what we really want to get out of this day, some productivity interactions. We will hear a presentation about 3 topics from our experts in ISMC, 3 topics of Horizon Europe. For those of you that are not familiar with Horizon Europe, the program identifies some specific challenges they want projects to address. And of course, they give money for that, so this is also what we're here for. And making sure that we understand the topics, and then we will have this matchmaking session where you can choose one of the 3 tables to sit at and start discussing how to put together a proposal. This is not the final step. This is the first step to start working together to put together a proposal that hopefully will become a successful project for the next 3 or 4 years. So, without any further ado, I would like to introduce the first session. We'll have, I think, about 15 presentations if all the presenters are here. And we'll divide them in 3 main groups. The topics will be advanced processing technologies, sustainability technologies, and exploration and traceability. So more or less the topics that you saw yesterday in the 4 breakout sessions, and we're trying to group them together. These presentations, as I said, will be very short, we'll be very strict with time to make sure that everybody gets a chance to present what they want to talk about. And then we will go for the coffee. And finally, we'll come back together and we'll have working groups and working tables. I think we'll let the last few people coming in, or yes, please join us. No problem. And in the first session, we have five companies, sorry. And the first one is Técnicas Reunidas, and I'm going to put on the presentation, and I welcome the first representative here, which I've already forgotten names. I'm terrible with names. That's why it's good to have the packet. Yeah. Yeah. Okay.
Thank you. Okay, well, good morning. Well, first of all, thank you. Thank you, the cluster, for inviting us to present our work. I'm Ignacio Raiz. I'm Business Development Engineer within the Commercial Department of the Proprietary Technology Development Division of Técnicas Reunidas. I'm going to make a first brief presentation of Técnicas Reunidas, then I will present the division where I belong, and then I will talk about our process technology based on hydrometallurgy, and then I will present some industrial implementations and ongoing projects. Okay. I think you probably know what is Técnicas Reunidas. Técnicas Reunidas is a Spanish engineering company. We are an EPC contractor. We build industrial plants, basically in the energy sector. Our main business areas are the oil and gas, petrochemistry, and natural gas refining. But in the last few decades, we have moving towards energy transition. We are also involved in all that is related to hydrogen, CO2, biofuels, biomass valorization, anything that is related to energy transition industry. Here you can see also some highlights of the last year. For you to know, we are based in Madrid. We are around 9,000 people. And last year our net revenues in all projects were 4.1 billion. And we try to aim to minimize we try to help and minimize development costs, preserve maximum environmental commitment with the customers. And here what I show you here is a full range of services we provide the customers. We are not only now providing EPC, which is engineering, procurement, and construction, but also we go below that and we start from the conceptual design, research and development, and also basic engineering and FEED, and at the end, EPC construction. But today I'm going to talk about my division. This division, the technology center, was created in the 1970s when customers came to us asking for solutions. They were having problems in some of their streams. Some impurities was found there. And based on our knowledge on hydrometallurgy and electrochemistry, we start developing process and technologies around these ideas to recover key elements, non-ferrous metals elements that were found in facilities when we were producing zinc or other elements from primary ore, for example. That was the main idea, and at the end, the strategy. And the technology center was created at that time, and nowadays we are more than 60 people. And the division is split in 3 departments. One of them is biorefinery, where we are able to produce added value products from lignocellulosic using our knowledge and expertise on electrochemistry and hydrometallurgy. The second one is energy transition and environment, where we are involved in hydrogen production, electrolysis, electrolyzers, design, optimize the electrolyzers in order to reduce the capex and opex, and CO2, also capture, storage, and valorization as well. And the last one, which is the topic of today's meeting, is the metals and CRM circular economy department, where we recover elements mostly from the smelters to recover elements like zinc, cobalt, silver, well, any elements that is within this stream. As I said, we are engineers, but also in our division we are technology providers. Okay, our business model is basically based on we develop, we protect the technology, and we sell the technology to customers via licensing. Okay, and at the end we are able also to provide the EPC, the construction of this, the implementation of this technology in their facilities. We are able to treat any kind of raw materials, from ores, concentrates, liquids, but also it's important for you to know that our advantages in front of the traditional methodologies that are in the market nowadays, roasting, leaching, electro-winning. Our goal is we are very good at very impure streams. So our advantages is on secondary raw materials, where you can find a lot of elements at low grade and low content. So we also work from industrial residues, municipal residues, and industrial byproducts. We are able to extract, for instance, phosphorus. We are able to extract zinc, and we are able also to produce super high grade zinc at the end. That is a selling price, a selling product. The core of the division is, I'm not going to enter into detail about this, but just for you to know, our main technology processes is solvent extraction. What we do is to use an organic phase in front of a pregnant solution with the element of interest, and what we do is to extract this element using the organic phase, and at the end, in the extract phase, we have the element with the organic phase, and then we wash and strip, and then we recirculate the organic phase. And we are able to produce a ultra pure element at the end of this process. Okay? And this is important that we manage all the steps to optimize it and reduce OPEX and at the end also CAPEX. Here I show you the portfolio of the different elements and the level of TRL we are at the moment. We started. We can say that we started at commercial level. The Thintex process is a technology that is able to produce zinc from primary ore, but also from secondary. Basically from a source of zinc oxide that cannot be found in the mine. There are some specific mines, for example, in Namibia, in Africa, where there's a specific polymetal mine where you can find a zinc oxide, and then we treat it, and we have covered and developed a technology around that. Also, we are able to recover lead, phosphorus from ashes from the sludge. So the waste water treatment plants, they produce a sludge and then it's incinerated, and the ashes that are produced, we are able to extract the phosphorus and produce phosphoric acid. Also, we have involved in a technology based on rare earth. We are able to produce neodymium, praseodymium, mixed rare earth carbonate, and also neodymium, praseodymium oxide from monazite, using our knowledge in that. Also, we are involved in the recovery of lithium, nickel, and cobalt, starting from black mass, manganese. We can recover manganese from from a secondary stream at the end. Here I just show you a list of references, more than 100 references of our work during this time, and 5 licenses plant. This is just I will go quick because we don't have too much time. We can discuss later, but here I just show you the 5 industrial references. I just highlight 2, one with Glencore in Italy. We are able to produce 52,500 tons per year of zinc starting from wealth oxides. These wealth oxides came from the steel industry. You should know that zinc is used for covering the steel in order to protect the corrosion. So from a secondary sources, we are able to produce the zinc. Also in the US with Befesa, we are also able to produce more than 1,000 tons per year. And here, just to show you the successful ongoing projects we are involved in nowadays, as I said, we are also able to recover other elements, cobalt, gallium, which is very important in the US nowadays, to recover gallium and to reduce at the end the dependency with China. It's important to see that. And on the left, you can see one R&D project we have achieved, because all these projects are developed based on public fund, using European fund, but also private fund. Okay, and permanent is we will create a network of around the permanent magnet production. Thank you so much. I'm sorry. I don't know, you have questions or when the question will be later?
No, we'll do the questions later in a more relaxed way when we have the coffee break. Remember, Ignacio, if you have any question for Técnicas Reunidas, thank you very much for the presentation. Sorry to pressure you, we've got many to go through.
I saw you.
But
don't worry.
It was really interesting to hear about the rare earth that you mentioned, even the energy sections, the technology. I think there is a lot of food for thoughts already to start thinking about future projects and ideas. Thanks also for mentioning Permanet. We are in that project as well, and I think it's very good. So thank you very much. And this is just to give you a gist of what we're looking for today. So companies that can present their profile, maybe their ideas, maybe their proposals, their strong points, maybe their challenges. The next company that we invite on the podium is Kubikoft. As I said, I'm terrible with names. So is there someone from Kubikoft here? I'm going to put your presentation. And have you got a presentation here? No. Okay. Just talk. Okay.
Well, we'll try to do just like Steve just said. If you need a presentation, you know very well what you want to say.
Thank you very much. You have 8 minutes starting now.
Sure. May I close the laptop? No. No?
Sorry. Yeah. We'll put your notes here.
Yeah.
And they should if you close the laptop then.
Okay.
Okay.
Okay. Fine.
Maybe 5 minutes. So don't worry.
Oh. Okay, nice to meet you. Hello, good morning, everybody. My name is David Perez. I'm industrial engineering and CEO of Kubikoft Open Engineering. We're an engineering company that is dedicated to solutions of engineering for the industry. Very transversal in sectors, and minery is one of our main sector, mine and energy. I invite you to visit us in our stand in MMH. I have no presentation today because I was going to talk just in a very few minutes about a project that we are exposing at the stand 2031 Pavilion 2 at MMH in the exposition that we are closing today. Okay. The project that I'm going to talk, we've been doing the detailed engineering of a recovery project coming from an European consortium that it's called Recovery. It's promoted by the EIT Raw Materials, and main actors are Minera Los Frailes and Setaqua. Over the consortium, there are several, like CSIC or the UPC and other companies. What we've done at Cubico, we've done the detailed engineering of this process. The process tries to recover rare earths and some metallic sulfurs, where we can find zinc and we can find nickel as main metals, coming from the acid waters that are already at the Corta Aznalcóllar. I don't know if you know the situation for Minera Los Frailes. They have two cortas. One is Aznalcóllar with acid waters that they had to treat, and they have to get empty, that corta. And the other one is Corta Los Frailes, that is better water. They have to treat it also. From Corta Los Frailes is where the tunnel, the attack tunnel, will become 80 meters below the level that we have from water now, for the next gallery exploitation, okay, underground exploitation. We are talking about the other one, the Aznalcóllar. Those are acid waters, complex waters, and the idea is try to recover metal materials similar to the exposition that my colleague Ignacio has talked right now. And well, it's, as I told you, we have the scheme, all the PNIDs in our stand. If you're very interested in we have it in our stand at Cubico, and in front it's Minera Los Frailes. Both of us, we have the PNIDs, and our engineers could explain better any detail about the process. The process it's a pilot plant right now. It's the idea is to pilot in a batch functioning, between 5-10 cubic meters per day, and the process basically it's we have a primary decantation where we try to separate anything related with aluminum or ferrum that we had, or iron. Afterwards, it goes to a biological treatment. Then we have a secondary decantation. Afterwards, that we make a dissolution and crystallization. We make both HRE and LRE ionic exchange treatment, and for this crystallization, just to get metallic sulfurs. Into those metallic sulfurs, we can find most of it zinc and nickel, and a separation of rare earths. Afterwards, we go through both treatment nanofiltration and narrow reverse osmosis also, just to make a final filtration of those waters. Just make a point that this is not water treatment, but a treatment to try to recover value materials from the waters before treat them and to waste them to the river that I don't know if you know, we have Guadiamar River very close, but there will be a long pipe to send those waters after the treatment, to send it to the Guadalquivir River that is about 30 kilometers from the mine, from Aznalcóllar. Okay, so this is very, very quickly and without any scheme, very quickly the treatment that we're making there. The pilot plant has been designed, well, between last autumn and this spring, 24. Has been decommissioned, I guess, April, May, and it's functioning since that date. And I guess it has been 2 months, about 2 months, 3 months that it's now having some results, not 100% what we could find in all those schemes or PLENARY that you will see. The idea is to recover 1 kilogram of metallic sulfurs, where we can find things, zinc and nickel. Okay, 1 minute? Good. Yes, more than enough. And all the team, we are very excited about the results that we are finding. And well, the idea is if this pilot plant has the result expected, is to build an industrial plant, just to cover the whole. I don't know right now how many cubic hectometers it has, the Cortaz-Nalcollar. It's a lot of water, so we could find over there a recovery of rare earths and those metallic sulfurs. Let's see if we get it. And the next edition of MMH, we are talking about the industrial plant for recover this metal from Cortaz-Nalcollar. Okay. Thanks really much, and you're invited to our stand.
Thank you very much for the presentation, very interesting, and also, yes, doing without slides, I think is very helpful because you really capture the attention rather than just looking at the screen. Just a couple of points to take on. You mentioned the EIT raw material, excellent. We work with the EIT raw materials, we're a sponsor of it. I think it's a very good also framework to discuss projects. And also you mentioned pilots. I think to bear in mind for future projects, what we always try to do is to start with a pilot. European funding, Horizon Europe, helps you to prepare pilots to scale up technologies in the future. There are, of course, different TRLs, but this is also an important element to take on board for a future discussion. Thank you very much.
Just think the pilot, it's about 500 square meters.
Yeah.
And all the equipments are more than compressed. You know, just like surgery in a can. Yeah. So the pilot might be, we could call it a little industrial plant more than a pilot, but that's good. But it's still being a pilot.
Excellent. Thank you very much, and it's my pleasure now to call on stage Raul from EcoCastellum, and EcoCastellum is also one of the members of the cluster of the ISMC. And we are collaborating on a few projects. So, Raul, there is a microphone there. I'll put on the presentation for you. Yeah,
that one.
That one. Okay, just use it.
Hello, good morning, everyone. This is a pleasure to be here today, and thanks for providing me this opportunity for discussing, for introducing this approach that I hope you will like. Well, my presentation consists in the following: to explain you what does it mean a smart valorization. But first of all, I will introduce myself. My name is Raúl Carrillo. I'm Chief Research Officer at EcoCastellum, but I also combine this activity being program manager in one transportation technology company. So you will understand the duality of my position, trying to understand what are the needs of the transportation sector and how we can mitigate the negative impacts providing raw materials for covering the CAPEX and the OPEX and all the transportation needs. So I will start with the introduction of EcoCastellum. EcoCastellum is a technology company based that was founded in 2022 and is basically composed by a highly qualified multidisciplinary engineering team covering the different aspects of the engineering, such as the mining industry, but also the industrial needs, okay? So the purpose from the beginning at EcoCastellum has been to be really focused on providing sustainable solutions, and that's why we implement as a kind of internal strategical approach, corporative approach, the triple S. That means sustainable solution system that consists in different steps. One of them is to provide a smart valorization of the mining waste that are produced in the different mining sites. Also to encourage a new engineering discipline for developing for verification and validation of new advanced materials in order to supply different needs of the different sectors, but also to improve, to create a better technological processes in order to decrease the negative impact. So from the beginning, the philosophy of EcoCastellum has been to be focused fully aligned with the mining sector for a good reason, because it's essential for the society, community, but also from a strategical standpoint for the European Commission. So the next slide tries to summarize in a briefly way the key motivations for the smart valorization, for the sustainability achievement in the mining industry. One of them is first to understand what's the role of the supply chain. Okay, the supply chain, especially in the mining sector, is really crucial because it provides a lot of raw materials from different associated industries. But also, we have to understand that the mining has different associated impacts. Activities like processing, extraction brings negative environmental impacts that therefore are accumulated into the life cycle and CO2 footprint determination. Having in mind these two premises, we applied that smart valorization that consists in the following: to decrease the extraction of those raw materials through that smart valorization, but also to provide innovative solutions at the level of a pilot, reaching the TRL 7 and 8 ready for entrance in the market, okay? But here we have a great duality, that we can have direct raw material source from the mining sites, but also indirect, trying to get from the calling down industries some specific materials that could decrease the use of chemicals. So that's how the triple S, the Sustainable Solution System from EcoCastellum work. We have 5 phases: the detailed analysis of the needs of the mining sites. Then we have, once we take the waste, characterization program. Phase number 3 that consists to understand the capabilities of that material based on the compounds, minerals, etc., to determine if it is critical or strategical, etc. Then to see what the characteristics of this potential material, what's the market that we can fulfill, what are the specific needs of the market, and then the phase number 5 that consists in verification and validation of this new product and to create a new business model strategy with a plan for the short, medium, and long term. So then we have a real case. Today at EcoCastellum we have a real case that is focused on railway applications. Taking the raw materials from the mining industry, in this case is the slate stone cutting slags from Matacota, which is the biggest mining company for slate stone in Spain that has huge accumulation of this mining waste with no further uses. So taking those premises that we also understand that it's a good material for creating geopolymers, which is the potential material, we focus on one specific market, the railway. The sleepers. The sleepers is the concrete material that supports the rail. And why this material? For a good reason, because we want to decrease the capex and the opex of the railway infrastructure. Why? Because the European Commission wants to promote, to encourage the high-speed railway construction by 2030 with a minimum of length of this kind of infrastructure, because it's a clean transportation mode, more efficient, etc., etc. So many associated. So today, we have a pilot, as I said, using geopolymer. The geopolymer is not a theoretical material that works as per Davidovich, no. Today, we already tested with a pilot. We went to the full requirement list of the Spanish railway administrator, we already feel it, and we have a material which is better than the ordinary Portland cement. Besides that, we reach 39 megapascals, which is more than the 30 required by the ADIF railway sleeper standard, which is a great advancement. Why? Because we have less consumption of raw material, we are recirculating those materials, we decrease the chemicals, we don't need temperature, and it's more stable material with a demonstrated durability on rust environments. So, today we got different conclusions, 4 of them, that there is a consolidation of this system in the mining sector. There is a strategy, can be applied, and we can find some materials, which is the conclusion number 2. We have the tools, we are the right engineering company for doing that. So this is a new engineering discipline and an eco-custom. We are providing key-term project on sustainable management, valorization of waste, eco-products development, CO2 capture certification, because we have the potential to do it, business opportunities. So we will have an expansion to European countries, because we can use raw materials not only for the mining sector, even for construction and demolition waste. So you can see the great advantages. So this is the sustainable management, that is part of our philosophy in the company, that we are fully aligned with the reforestation and recuperation of the mining sites in order to decrease the environmental impacts, and the different collaboration and network opportunities that we will have through the European funding projects, private investor, or mining operators. And here we have our team, Ignacio López, he covers the compliance of the mining legislation, Francisco Corpas, our Chief Technology Officer, myself, Chief Research Officer, Juan Isidro, Advisor in Environmental Sustainability, Elena Picazo, my Chemical Engineer Department Manager, and Griselda Perea, our Chemical Engineer. So you will see that we have a multidisciplinary team covering a great spectrum of the engineering field. Questions, we will have later time for discussion, and here you have my details for any kind of questions. And for the next time, more time, please. I went too fast, I'm really sorry. And that's all, thank you.
Thank you, Raul. That was a fantastic presentation of the many wonderful things your company, and still early stage company, does. And I was impressed by the Triple S. I live in a world of acronym. We've got S3, and you have a different 3 S's. But what I was impressed was the connection between recycling mining waste, putting it to use for clean transport, and reducing the production of cement. So these are 3 S's for sustainability, sustainability, sustainability. This is where we're going with these things. So thank you very much. Any question later on, we'll have time at the coffee. And thanks for being on time, of course. And the next presenter, and I keep forgetting the names, but you know who you are, and you'll present yourself. Rotodina. I remember that last minute. Let me come here. Yeah, we're going to give you, I don't know about the videos. You've got 8 minutes. You're welcome. They will try to do something. Okay. Okay. Just use this. Okay. Thank you.
Does this work? Perfect. So, good morning, everyone. My name is Alex, and I will be presenting on behalf of Rotodyna, a university-to-market technology transfer startup company from Serbia. And to indulge our host, our acronym is therefore U2M. Okay? So the reason we are presenting here is to hopefully shed some spotlight onto the problems and the challenges, namely, faced by the Critical Raw Materials Act from the standpoint of production. For you see, many of the materials covered by the Critical Raw Materials Act require the use of mega machines. And we are talking the machines such as bucket fill excavators, reclaimers, stakers, combined staker reclaimer machines, and ship loaders and unloaders. But regardless of the name, the key word for all these machines is extreme. We're talking extreme size. For example, this one is 100 meters long by 50 meters high. We are talking extreme mass, where the baby machines, so to speak, are several hundred tons of mass, and thousands of tons is usually the norm that we talk about. We are talking extreme price tags, 10 euros per kilogram of the machines, roughly. Extreme production measured through the capacity of production of the materials, which is measured in millions per year in revenue for the users. And finally, extreme lifespan, because all of these machines are designed to operate for decades, hopefully. Two sides to every coin, so we also have extreme problems. The problem of production is the problem of downtimes. So if the revenue is high, then 1 hour or 1 month or 1 year of standstill of downtimes is extremely expensive. But this is taken to extreme because some of these machines, by their design, are predestined to collapse. And this problem has a price tag measured in millions for repair costs, but the revenue losses due to unrealized production are orders of magnitude higher, and unfortunately, usually it takes a lot of time to repair these machines and put them back in operation, so the costs are huge. And consequently, we have disruptions of the logistical chains and the industry sectors that rely on the steady supply of raw materials are now faced with material scarcity, and that is reflected on the price or availability of the end product. This problem does not discriminate and is a repetitive issue all across the world for all of these machines that we have talked about. So a typical cycle for the end user, and by end user I mean open surface mines, open storage facilities, processing facilities, ports and such. The typical cycle looks like this. They have a machine in operation, then the machine goes into a breakdown and a standstill, so the company is losing money. They do the repairs on themselves, and the machine is back in operation until it breaks down again, and they are losing money again, and they do the repairs again, and the cycle continues indefinitely. As a result, the average uptime of these machines on the surface of Europe is very low. It's roughly, for the bucket wheel excavators, it's roughly 40% of uptime, or 40 hours per 100 hours. And the main reasons behind the standstills are classified as electrical or mechanical breakdowns, repair periods, or 15% are declared as other types of downtimes. But a bottom line, a common denominator, are actually the appearance of excessive vibrations, and sadly this video does not work. Maybe if I do this. Perfect. So the excessive vibrations essentially mean that the machine starts shaking wildly, and that significantly reduces the lifetime of the machine. And the underlying reason behind all of that is that the governing regulations and standards, the rule books by which the machines are designed, do not cover, with sufficient guidelines, do not cover the aspect of dynamic behavior analysis, i.e. prevention of excessive vibrations, and as a result we have oversights in the design and ultimately decreased production, and sadly in the case of catastrophic breakdowns sometimes people will lose lives. So, when they're fed up with the repetitive cycle of repairs and downtimes, they are forced to seek the help of specialized R&D people at the research institutions. In our country, those are the University of Belgrade, Faculty of Mining and Geology, and Faculty of Mechanical Engineering. So the company has a repetitive problem, they come to us, and then we do one or all of these activities, which are development of digital twins in order not to stop the machine but to do the prototyping in virtual environment. We then do stability calculations to see if the machine is well put together, so to speak. Do the strength analysis to identify the weak spots in the machine. Do dynamic behavior analysis to identify favorable and unfavorable working regimes for the machine. And as needed, we do on-site measurements for the purpose of diagnostic and identifying the state of the present machine. We then return a permanent solution. Excellent, but that's just for one machine, and that's after the problem has already occurred, usually multiple times, at the rate of 2 million euros per 1 month of downtime of the machine. So we try to approach this problem and say, can we address this issue proactively, preventively, and predictively, and prevent the problem to occur instead of treating the consequence every time? And the answer is yes. We have developed a unique and proprietary method for the full assessment of these machines, so to speak, in advance. So a device can be produced which protects the machine by semi-automating its operation. A caveat of all this is that such complex machines require hundreds of thousands, if not more, of extreme intensive calculations. So those are very computationally extensive and demanding. So we needed to develop a hardware platform to make it all happen. Fortunately, there were university to market technologies transfer grants. Some called them smart specialization strategy grants. And we were able to receive one of such grants, form Rotodyna, and then shortly after forming the company, developed the algorithm and the software for this decentralized distributed computation over a distributed network of computers. And shortly after, developed our first prototype in the form of a device which, if the unfavorable operational parameters are set by the operator, the device adjusts them automatically before allowing the machine to operate. So the current paradigm, where you have repetitive downtimes at a very expensive rate, due to having unknown combinations of operational parameters, these are suddenly made known for the machine. Those are completely mitigated, and as a result, and as a small bonus, the additional uptime is received through the minimization of minor repetitive breakdowns. Shortly after, we have heard about a competition organized by DIT Raw Materials for the best technological innovation. We were fortunate enough to win it, and that opened the door for us for the DIT Raw Materials Acceleration Program, which is a part of Horizon 2020 program. We received the grant, we were part of the program, and with their help, we were able to do the full market analysis and develop the business model for our company and services. We also did our first 2 industry projects for the industry, and thus again validated our underlying algorithm behind the product. This year started with the second phase of the accelerator program, third industry project, and shortly before this meeting, we started the third acceleration program dedicated to developing, to finalizing the product for on-site testing. We need to install it on a machine, undergo extreme tests to prove that the device itself, the physical aspect, is durable enough. After that, the program is market ready. This is the final step. Next year, we expect to finalize that, negotiate our first sale, and expand our team and look for partners for the market rollout of our products in the EU. With that, I would like to conclude. As the host has said, the time for questions is at the coffee break, so you'll find us either there or smoking in front of the building. Thank you.
Thank you. Thank you very much for an excellent presentation and really insightful in presenting it clearly. I think it's really striking to understand what can be done before and what can be done also with the European funding and go through the cycle of different funding. I work for the ISMC. We specialized in getting companies to European projects, so it's very good to see a successful company to do that. But from your point of view, also a successful company to do all the technology, software, and business development activities as well. So thank you for that. I'm sure there will be plenty of questions later on.
Always a pleasure.
The next speaker is Juha from GTK. Yes. I don't know if I pronounce your name correctly, but you introduce yourself. And Juha is also a long-standing partner in many European projects with us, and representing also the S3P mining regions. I don't think there is a presentation from you.
There is, yeah.
There is? I didn't get it here. Tanya, do we have a presentation for... Sorry about this. We'll get board in a second.
Well, I sent it anyways.
Yeah.
I really cannot do the presentation without slides because I'm coming from the Energy and Construction Solutions unit of the ICAMCyL Finland, and the GTK is a important part of the ICAMCyL Finland, which is a governmental research organization. And I'm giving this presentation on behalf of GTK. next one could speak, and if you try to find it
Yeah,
later,
that's a good
because we
idea.
are losing time here.
Okay. Bear with us a second. No, we'll. Okay. Just give me a second. We'll try to get it on the system in a second. So sorry.
Yeah,
Luca.
but,
And we'll
yeah.
go on to the next one.
Next one, yes.
Yeah. Huh? Okay, we'll talk to this. And so, sorry about the little hiccup here. This concludes the first part of the presentation, but we'll get Yuka in the next one. We can move on to the next set of presentation, and I think we've got Francisco from Congeo, and I hope you're ready. And I'm sure we have this presentation, and we'll put you online straight away. Okay, and Francisco in Congeo is another company that is a member of the ISMC, of our cluster, so it is our pleasure to welcome you on the stage, and the floor is yours, Francisco. There is a microphone here.
Thank you. Let me try if this works, okay. Congeo is a small consultant company based here in Spain. We are focused on studies related to water, and we are part of the Live for Life project, in which we are dedicated to evaluation of mine impact risks to water quality. Our aim is to help society minimize the environmental impacts from mining industry and other sectors. And as I told before, we are focused in studies related to water, hydrogeology, hydrochemistry, environmental geochemistry, mine waste management. Our key objectives in the Live for Life project is help better assess the risk of water pollution from mine projects and get the maximum information from short-term tests, usually carried out in mine waste characterization, but normally they provide little information, while we think we can get more information from them and help assess the risk. The regulatory framework for mine waste characterization is those two decisions of, there are two European decisions of April 2009. And in Spain, we have the royal decrees. One decision is mainly based in the definition of inert mine waste, and the other European decision is more focused in general characterization. And inert waste is mainly defined on whether the mine waste can get to solution, combustion. It contains all processing substances, but this is not the main issue. The main issue is the content of sulfide sulfur and the neutralization potential compared with the acid potential ratio. There's a definition that. And the chemical analysis, which is supposed to be below some threshold values, which are taken from the soil pollution regulations. And we think we can go further from this point. And also, there's a point regarding prediction of drainage chemistry in the European decision and the Spanish legislation, I guess in other European countries' legislation as well. This is an open point, how to predict drainage chemistry. It points out some leaching tests but it is not precise on what test is to be carried out, and also how to do the prediction of drainage chemistry. There's not a standard prediction worldwide in the geochemical community. There are arguments on how to better predict drainage chemistry. And in fact, there's a study in the United States carried out about 1 decade ago that says that most predictions were wrong. Most predictions worldwide regarding drainage chemistry were completely wrong, and that affected the mine waste management. So most mining companies go for the characterization following the definition of inert mine waste, which is misleading, but for mine companies is kind of the easiest way, because if they characterize the mine waste as inert, then the requirements for management are low. But as we say, that definition is misleading. And we prefer to go for assessing risk, environmental risk, without going into the details of the prediction of water quality, and knowing the risk, then manage the mine waste properly. So the main focus is if there's a risk of significant pH change, a risk of liberation of substances, in our case metals or sulfates, or other substances as fluorides that come from the lithology. And also we focus on the vulnerability of the receiving environment. We focus on leaching tests. The European standard 12457 is a test normally used in landfilling, which has been recommended by the Spanish Mining and Geological Institute for also mine waste, but it's mainly focused in waste dumps. And we are trying to get information from the NAS test. The NAS test is a net acid generation test. It comes from Australia. Mining companies normally do this together with the ABA test, that there's a European standard for it. And the NAC test simulates weathering of sulfides in a short-term test. So we also analyze the leach, the eluate from this test, and try to prove a risk. This is an example of what we are trying to develop. We have proved this in 2 projects. And as you can get information comparing with the national water standards for surface waters, or for groundwaters or human consumption. You have standards, and then with the short-term test in laboratory, you can assess what risks you have of liberation of some metals, and from this establish mine waste management criteria. Regarding the receiving environment, the water, we want also to establish an environmental risk based in permeability tests that normally are carried out during the drilling phase, and also some other parameters as the water table depth. And from surface water, we want to study also how to connect the ecological flow in dry period and establish a risk based in that surface water flow, and also the amount of mine waste that is predicted to be produced. This is our main team for this project. We are geochemists and hydrologists. We have incorporated another person, Anna, which is also here. So the conclusions of what we are trying to do is we are starting from the concept that the characterization as inert mine waste is misleading, though it's normally what companies go for. We need better preliminary risk assessment, incorporate mineralogy and leaching in the suite of geochemical laboratory test work, and try to develop a risk index that can be used to establish mine waste requirements without going into further, more extensive and demanding laboratory test work for predicting mine water quality that normally gets to wrong conclusions. So thank you very much.
Thank you very much, Francisco. And I think, again, it was a very interesting presentation about the risks, but this time about sustainability and environmental risks. In fact, your session is about sustainability. I'll take you back one step to the previous sessions, and I welcome back Juha. And I'm sorry again about the mess up with the presentation. I think...
Nice to see you again. Actually, it was my fault. I eventually didn't send it. It went to the wrong address, so my apologies. It was not your fault.
Don't worry, don't worry. The most important thing is to have you here. The slides will always arrive. So let me see if I can get on this. Juha, finally the floor is yours.
Yeah, thank you. Yes.
Thank you very much for your patience.
I'm Juha Kaja, Senior Specialist from GTK, and I will give this presentation on behalf of GTK Mintec, which I already mentioned that is part of the Geological Survey of Finland. And GTK Mintec is also part of the Outokumpu Mining Hub, which is in the Northern Karelia region. GTK Mintec is one of the funding partners of this Outokumpu Mining Hub, and it consists also partners from companies, mining companies, technology providers, and Business Joensuu, and they are providing services for the mining industry in their needs. So this is GTK Mintec shortly. It's a unique mineral and circular economy research infrastructure in Northern Europe, located in Outokumpu, North Karelia, and it consists of like complex mineralogy and a mineral processing laboratory and a pilot plant. And it offers business, public sector and research communities unbiased research related to the entire value chain of the mineral processing. And nowadays, one of the most important part of this GTK Mintec services is circular economy issues. And there are 50 professionals work at the pilot plant and laboratory, and they have like around 100 projects every year, of which 8 to 10 are pilot scale research. And this is the aerial view of the facilities. We have a new laboratories and offices. They were actually opened just last spring, and there will be smart test field, which I will talk a little bit more later. And next year there will be this new pilot plant will be, they will start to build it. It will be totally renovated within 3 years' time with up-to-date modern equipment there. And this is part of the GTK Mintec service offering. We are doing circular economy materials research and studies and contract works, tailings, slags and other geomaterials. Of course, base metals, industrial minerals, because this was in the beginning, GTK Mintec was only doing the base metals and industrial minerals research and contract works. And of course, nowadays, battery minerals and metals are more and more important for us. And this is partly because of this need for research of the battery minerals, lithium, graphite. We got the funding from the Finnish government to build up or renovate the whole pilot plant. If I remember right, it was like 80 million euros from the government, only for the pilot plant. And side streams and secondary raw materials and water solution for old tailings, remining, research related to water, recyclability, these are also important part of GTK Mintec. And also mine closure, they are also providing services for mine closure and mine after mine management. So We are developing ICAMCyL, the world's best digital laboratory and pilot plant complex, focusing on mineral processing, circular economy of minerals, and mining environment research. And at the beginning, there was a small map that was actually the network of our clients. And we serve the domestic, EU, global actors to speed up the green transition. And I already mentioned that in the pilot plant there will be latest technology, but there is also in the new facilities in laboratory, the equipment is really impressive there. I'm not a specialist in that branch, but if you are interested to visit sometimes Outokumpu, North Korea, you are more than welcome to visit there. And this is like ICAMCyL 2.0. As I mentioned, there was a laboratory and office renewal, and it's still ongoing. But what I wanted to emphasize is that this smart test tailings facility, they started to build it last year, and it's a research infra for tailings management methods. And you can do short and long-term behavior environment load research there. And there is also one part is the dry stacking research, and it's a part of the second pilot plant process line for water circulation studies. And new pilot plant 2025, in 3 years' time, it will be built. And it will be also equipped with pilot plant scale equipment for water purification and recycling and tailings dewatering and processing research. This is actually related to this smart test field facility. It's a project called MineCoin, also funded by the European Union and North Korea region. It's an innovation platform for sustainable mineral economics, and the aim of the MineCoin is to build research platforms in connection with GTK's Mintec pilot plant and research laboratories. And this smart test field facility for side streams and management of extractive waste is the most important part of this MineCoin project. And as a result, the project is completely new research and innovation platform for the study of mineral-based side streams and tailings formed in the extractive industry at ICAMCyL. This is just a simple picture of this smart test field test facility, and it was co-funded by the European Union, not totally funded, but anyway, we are pleased to have this fund from the European Union. And the total budget was around 1 million euros, and of course EU funding was quite large for that. But this cover test facility, it consists of large-scale lucimeters and small-scale lucimeters and some other monitoring equipment installed in place. And here are some links to the video materials, and you can also find them on our website, GTK website. Thank you.
Thank you very much, Ilkka. Thanks for the presentation, and it was impressive to see the best digital lab. I think you really aim high. I think it's very good. And thanks for the invite to Karelia. I think we may take it. We may take it on maybe a project together there. Thank you very much. We'll go back to the sustainability session, and I think we've got CJ presenting here. And just give me a second, we'll put on the presentation for you. You can use this or the others, as you prefer. Thank you very much. The floor is yours.
Thank you. Thank you, the cluster, for the invitation. Morning, everyone. My name is Cesar Junco. I'm the Managing Director of CEA Sustainability Solution. We are a boutique consulting firm specialized in health, safety, and sustainability projects. We move from technical background presentations to another relevant topic for the mining industry, as it is safety. Nowadays we are talking about the sustainability of mining companies and other type of companies, and obviously a company cannot be sustainable if there are serious incidents or serious injuries. So I'm sure you'll agree with me that is one of the most relevant topics historically in the mining industry. As you can, in case you have some questions or you want to know more about the hub, or have the link to the video. Thank you.
Thank you, Cesar, and thank you for giving on time. I'm sorry to put pressure, but
It's okay, it's okay.
I think this is another S that is important. We talked a lot about sustainability, but safety also is extremely important to put in our projects. We work with mines, we work with very difficult environments, so safety for the environment, but safety for the people that work in there, I think, is extremely important. Next, I would like to make a little change on the schedule and invite to speak Core IC. If there is somebody here from Core, sorry about we call you a little bit earlier because we are shifting the agenda a little bit, and let me just get your presentation on. Or you can use this one. Thank you very much.
Thanks. Okay. Good morning, everyone. My name is Valia Eliopoulou. I'm here representing Core Group. So what we are basically a fast-growing SME. We were launched in 2016, and we're focusing on delivering Industry 4.0 technological solutions. So our main services revolve around harnessing data to provide tailor-made predictive maintenance algorithms and smart energy management for various applications in various industries, including mining sector. So basically, we have two major milestones in the group. The first one is the foundation of Core Innovation Center, which is basically a research organization, and it's leading the focusing on the twin transition, so the digital and the green transition. And the second one is the launch of our main product, which is the Corebit, and it's our signature all-in-one predictive maintenance solution. So basically, I will talk a bit about the product. It's a one all-platform predicting failures in real time of assets and basically extending the health of various assets, and it's based on basically vibration analysis and other parameters that we capture. We have three components, which is the hardware, which is basically the sensor that we deploy on the equipment in question. It's the deep learning AI algorithms that we develop that we can basically, after 2 months of training the data, collecting data, we can produce anomaly detections using this user interface, which is basically given to the user and to see all the alarms and warnings and critical warnings. And we have several pilot projects that we have deployed this product. Several kinds of industries in food processing, copper, wastewater treatment, and also in mining. So we have 2 mines that we have deployed this solution. One is Marine Marm in Italy. And basically, in November, our solution warned the operators for a critical failure in one component. They halted the machine, replaced the component on time, and really managed to avoid any damage and downtime and losses. And the second one is in Terna in Greece, a quarry in Greece, where we also have deployed recently the solution. The second milestone I want to talk about is the Core Innovation Center, which is basically a non-profit research organization, and it's a subsidiary of Core Group. And basically the aim is to develop an innovative ecosystem in Greece and in Europe in general. What we focus is, as I said, this Industry 4.0, and we deploy various technologies from machine learning, IoT, big data optimization, cloud computing, and edge computing. We have 4 units in the group. We have the digital transformation unit, the digital tools unit, the digital twins unit, and the energy and resource efficiency unit, which is the unit that I am leading. And, well, we are based in Athens, in Greece. We have in our track record participation in more than 50 EU-funded projects, in total of 24 million euro funding. And our success rate in EU-funded proposals and results is almost 30%, which is really extremely high. The average is around 8% normally. And we have more than 300 partners, quite a big network. And we are around 70 people, so we have data scientists in the group, software engineers, we have front-end developers, people doing marketing and communications, business modeling, and project management. And I want to talk about basically two EU-funded Horizon Europe projects, basically, that core developed the concept, we formed the consortium, we coordinated the contributions for the partners, and we wrote the proposal, and they got funded. So the first one is Mastermind. It's about turning mines digital and sustainable, and also keeping an open line of communication with the communities around the mines. Core's role in this project is threefold. So one is the digital transformation of the mines, so basically doing all the plans for digital transformation and coordinating this action, and also developing the middleware for all the mines. Second one is the predictive maintenance of critical assets, so from blowers and pumps and several kinds of assets that are used in the mines. And the third one is the fuel and energy consumption optimization of various equipment, trucks, and other machinery used in the mine. And on the bottom, you can see the different mines that are part of the proposal as pilots. So we have in Greece, in Poland, Finland, South Africa, and Spain. And the second project that we'll launch in January, probably, it's OptiMiner. It's very new. It's about efficiently recovering critical material from complex ores. So here, our role is again the data warehouse and middleware for the digital transformation of the mines. It's the critical raw material recovery selector. So basically, it will be a platform, an online marketplace where the users can, according to different criteria, match the critical raw material they want with the best available recovery solutions. And the virtual miner module, which is basically an NLP-based multi-role assistant for a complete user-friendly communication and process within this platform. And again, here you can see the pilots for this project. Again, we have Greece, Poland, Spain, Finland, and Chile. And I think this wraps it up from my side. Thank you very much for your attention.
Thank you very much, Valia, for an excellent presentation. It's really impressive to see such a young company to have success. And I'm pleased to say that as ISMC, we're partnering with you and with other partners that are here in OptiMiner. And we are in TerraVision as well with Core, which is one of the projects that is supporting the event. So really clustering together for success. Now we'll go to the next presentation on the sustainability session, which is from Nano Pau. If they are in the room, please make yourself known. And here we have your presentation. How are we doing here? Are we okay? Still awake? We're getting the last two presentations for sustainability, then you have the last sessions, and then you will have a coffee, but also the chance to ask questions, to mingle, to start discussions for projects. So just bear with us, and I think they are all very interesting presentations. They're covering such a wide variety of themes. The floor is yours. Thank you very much. No, give you this microphone. Over to you.
Thanks. Thank you, everyone. Thanks for your invitations. This is Kumar from Nanopower. I'm an entrepreneur, technical backgrounds, start a lot of different companies. So today, what is we want to talk about here? About recycling high purity silicones, advanced battery cell using for that advanced battery cell technologies. The technology actually comes from Japan. The Professor Hiroshi, he was after 2 decades, he developed the machines. That means he found the machines. This machine was producing a nanoparticle. It's a silicone nanoparticle. What is we are producing here, something is very unique, doesn't exist in the world. It makes a lot of headaches to get the approved license, production thing, a lot of things. So one thing I just want to tell you here, the story simply, if you found something in the world-wide, you know, it takes almost 50 years to bring to the market. Sometimes 30 years, 40 years. You see, bulb was found by Thomas Alva Edison. It took several years, GE Healthcare commercializations comes. A lot of technology like this. Here, we found a new machine, not discovered. That's the difference. So, what is this powder is using? You want to ask why this is important. Everyone talking about the cars, there's 2 elements is important for the batteries. One is how far you can drive. Second thing, how many batteries you need for one car. So here, even silicon has a 10-time capacitors because of the lack of technology side, lack of times, they are increasing at 3 times. Second things you can notice, thanks to the results from the professional battery manufacturers. So they're making a battery, it's a lot of recycling. That means you can charge, discharge like this, you can do several times. What is the effect here? You can see it. For one car, we're talking about several battery, or you can have one battery, you can for using several cars. That's the impact. So can you imagine how many CO2 you can save in the world-wide because of this tiny stuff? So this powder actually is a very tiny, it's a 3 times smaller than virus. Streptococcus bacteria, if you think, it's a 50 times smaller than bacteria. What is here we are supporting? There's 3 things we are supporting here, circular economy. I will come back how we support the circular economy. Why? Because we are taking a silicon from solar panels, which was defect, doing a purifications, and producing a nanopowder. This is the game changing. Thanks to the projects was Reslex. Second things, silicon, maybe someone knows, is one of the critical material in the European Commissions. It's a lot of demand in the worldwide. We are talking about 5 million tons Europe needs. Europe doesn't have this. Because already you heard about yesterday talking about between China, Russia, mine process, again battle with Europe. We need to be innovative. We need to be step forward. That's why we try to bring a silicon from solar panel. European Commission, they are very such a smart. They're pushing the entrepreneurs, pushing a scientist to do this. Why? All innovation, most of the innovation happening in Europe. We talk about America. They went to the moon. Okay, fine. But we also know we can bring something unique. So we have to be proud, be Europeans. Last thing, we are supporting energy. Why? It's going direct to the battery. So now everyone thinking about what the hell we are doing here in nanopower. Am I right? Yes. It's a simple 3 steps. We are taking a silicon from recycling from solar panel. We have machines. It's a black box, magic box. You can say this machine producing a tiny nanopowders. This is going straight to the anodes. What is anodes? You can see it here. Minus side, plus. This is the minus. We are increasing a capacity, putting in the silicon inside. Because battery has 2 elements, minus and plus. So we're putting in the minus, putting more lithium ions, increasing capacities. So, next level. You want to see about what we are in the value chains. Of course, already we have signed the agreement with the 7 big customers. And we see the demand in the futures. We want to increasing the capacities. Already demands is 300,000 tons. That means 2000 last year, we got a message regarding the evaluations. Battery manufacturers, they need 300,000 tons. But please think about one thing. We found one machine. This machine producing 1 gram per month, 2015. Now we're talking about something we need to bring, 300,000 tons per year. It's a huge step. It's a tiny step, 1 gram. Now we're taking a big step. They call 0 to 1 in the worldwide. So this is our predictions, how we are moving forward. So thanks to European Commissions, they are giving us support, EIT raw material giving us support. We have a lot of talent persons around us, networks. So we have 2 challenges. Even we have unique things. One is 7 customers. And second thing we thought about, we have a unique product. But unfortunately, we have challenges. So we moving to Spain. Why? Spain have a good harm? No. They have a talent persons. Spain has a history. So we're putting a factory in Spain. You see, this is a history. Second thing, of course, we're moving to Italy also. So, last thing, we talk about challenge raw material. How we want to sort it out. Thanks to EIT raw material, they make a telephone call. That was 2017. 17th of May, 2021. They asked me, Kumar, do you want to do something different? We will support you, back up you. So that's why we start a new company called CPow. CPow is doing a purification of silicon, given to nanopower. And these projects support more from RESILEX projects, thanks to you heard about the presentation, wonderful presentation yesterday. And of course, we got a new project called FOSIA, you heard about yesterday. So I can put all our networks worldwide. I just a brief information to you. Some of the battery manufacturers are here worldwide. So this is the RESILEX projects, thanks to this, full support we are getting. So this is the amazing things, how the coordinators, they are doing. They are really professional where they are handling these projects. That's giving me also more energetics to work here. That's why I'm standing here also. So Navox project, we are customer cells and everyone. You heard about customer cell bought by Porsche. That means we have already dealt with them. So these are the other projects. So I think my time is coming now. This is my teams. You can see it here. So Stina is sitting there, and we have others, colleagues are here. So the loss, what is our business model here? The clue is, we're taking powders from solar panel, CPAO is doing a purifications, thanks to European Commission and others, EAT raw material, everyone's. NanoPower reducing the size. This is going straight to the battery and making the world better. Thanks.
Thank you very much again for the presentation, and very good to see again some projects mentioned where we are partners together with ISMC, Trace you mentioned, and etc. So Resilix, and it's really a pleasure to see the network really working on the clustering. So plenty of questions later in the coffee break that is coming up. Next presentation, I have it on a stick, which is here. Give you the floor. 8 minutes, you have a timer here. Thank you.
Where is the time? I'm going to be brief anyway. Thank you, everyone, for your last bit of attention that you have. I'm going to be brief. We develop different services from what you could expect. We work with nature. We actually come from the conservation sector, and we have been requested 20 years ago to commence helping mining operations or in extractive industries to help them to have a better environmental performance. We are a team of about, let's say, 15 people permanent and can be increased up to 20. We are based in Seville, but we work all over Spain, including some operations in Morocco. We work with major mining companies and quarries, the cement sector as well. And we have an innovative approach to work with the environment, with nature. We use it as a tool, as a vehicle to boost social innovation as well. And what we try to do is to ensure that we maximize the levels of natural capital and biodiversity so the operations and the permitting process, they can have a better warranty of operations, ensuring the continuity of operations, ensuring a smooth permitting process, and so on. So let's talk about key messages. To restore nature, you need to know nature. And some people in here know that as a fact. We focus on ecological processes and functions as the key aspect of ecosystem that help us to ensure the provision of ecosystem services. Ecosystem services are the benefits that nature provides to people and society as a whole. The value of those services is called natural capital. If we use this approach and we embed this approach in the design, in the management plans, in the environmental impact assessment, and so on, we can ensure a more sustainable activity for the longer period. But we go to another level, because can we do something else for the surrounding areas? Can we integrate our operations within the surrounding areas? We know that the mining sector uses an amount of space, but we don't need all of it. We need all of it at a certain time of frame, a certain time, but not all of it. Can we do something else with that period of time? Can we help endangered species and critic habitats and so on to have a better conservation status? The reality is that yes, then we need to integrate this into the mining operations. But another key message is, if you need to restore mine, if you want to restore mine, you need to know mining. So the key aspect is that nature and mining need to understand each other. And we know that because we have the Critical Raw Materials Act, but in the environmental sector, we have another policies. We have the new regulations for nature rehabilitation. We have green infrastructure policies. And the reality is that mining sector has a major role to play before anyone else tells to the mining sector what to do. And I think we need to convert this vision into a positive way of working towards fostering the implementation of those European policies. This is a diagram that shows how we work with the different gradients of the environment by using the biotope of the mining to ensure that we have different ecological niches that ensure higher levels of biodiversity, that ensure the provision of ecosystem services. We have integrated this in a specific methodology because what you know is not important, it's not the main value. The main value is what you do with what you know. So we know all this, we get to know nature, we got to know mining, so we have combined this in specific protocols and methodologies, and we are changing the way that mining pits and mining activities are being designed. And they are completely compatible with the regulations. These ensure a smoother permitting process and a better warranty in the operations. This is one of the mine sites. In this Congress, we have, our clients have received 3 of our clients, up to a total of 5 different projects have received different awards for the environmental sustainability performance. We go to the basic design. Our colleague Francisco from Congeo, he actually understands part of this, he actually works on part of these aspects. The soil is a key aspect, and we work with those aspects. We need to know the environmental parameters that allow us to find those ecological niches and then continue building from there. We plan that. We don't need to be all the time in the mine. We plan that. We make a system for the operation to have their own resources, to plan ahead, to plan in the long term for the short term, the medium and the long term, and to monitor the results and communicate the results. Communication is very important because you not only need to do good, but also to look good. So communication is important. This provides a complete resource for the operations. We work with a temporary nature. What is temporary nature? The European Union allows us to mining sector, to mining operations, to maintain higher levels of biodiversity, even though you are going to extract in those areas at the later end. You have to only commit to maintain those levels of biodiversity in different areas. But it's doable and it's appropriate to do. So we make sure that we can increase the levels of natural capital within the mine sites and make it compatible, always compatible with operation. Without operation, we are not talking about anything. So we need to ensure that the operation is viable and we do not compromise the rhythm and the expansion plans of the operation. That is a priority and the rest come along. So the results, I've been talking about some of them already. Biodiversity net increase. A key message is that the mining companies play a major active role and should play a major active role in the European environmental framework as green infrastructure, connectivity, and the European Union Restoration Law. The environmental excellence, as per the experience, is a marginal cost at the end of the day. It's a marginal cost considering the level of cost that you have for maintaining the operations in CapEx and OpEx and so on. And we ensure that this approach is integrated in the land recovery management plans, the environmental impact assessment, biodiversity management plan. We deliver a set of tools that ensure that they are integrated horizontally and ensure a smoother permitting, and you have a proper ESG system in place, because all this report into your ESG system annual reports. And that's it. Thank you very much.
Thank you very much.
1 second.
1 second to spare. No, thank you very much for the presentation. It was very interesting. And yes, we do a lot of mining, excavation, and working with the environment, but we need to make sure that we, again, treat the environment as we need to. We're going now on to the next session, which is the exploration and traceability of raw materials. And we've got the 5 last presentations, so bear with us. There will be coffee at the end. There will be more talks among yourselves. The first one for this session is ICAMCyL, and once again, it is one of our members for the ISMC and also partners in many projects with us.
¿Qué tal? ¿Me encontraste? Esa.
Again, for you as well. Minutes, timer is here. Thank you very much.
¿Se escucha? Vale. Buen día para todos y todas. Primero que todo, una pequeña confusión. Preparé la diapositiva en español, pero bueno, cualquier cosa en la hora del café lo podemos hablar con más calma. El título de esta presentación es Inteligencia Artificial aplicada en la geofísica aérea, transformando datos en valor. Para dar un poco de contexto, Excalibur somos una compañía líder a nivel mundial que a partir de unos sistemas innovadores instalados en nuestras aeronaves, tanto plataformas, sistemas y sensores, nos dedicamos a mapear ese recurso natural capital, tanto de recursos renovables y no renovables. Contamos con más de 1.400 proyectos ejecutados, más de 50 millones de kilómetros lineales volados alrededor de los 6 continentes, con más de 40 aviones especializados propiedades del grupo, y en todos estos vuelos adquirimos información radiométrica, de magnometría, electromagnemetría, gravimetría. Contamos con imágenes ópticas, imágenes de radar, imágenes LIDAR y a nivel de geología con información de lineamientos, estructuras, litologías y trabajo en campo. Algo relevante es que todo esto lo tenemos integrado en nuestro visor geográfico, que lo hemos denominado Smart Geomap, donde básicamente lo que hacemos es compilar toda esta información que hemos obtenido alrededor de todos nuestros vuelos. Con esto es evidente que en Excalibur contamos con una gran cantidad, una vasta cantidad de datos y nace una pregunta muy importante. ¿Cómo podemos aprovechar al máximo todos estos datos para la toma de decisiones informadas en geofísica aérea? Es así como en Excalibur hemos determinado que tenemos diferentes retos. El primero de ellos es que nuestros geofísicos gastan mucho tiempo en el proceso de adquisición, procesamiento e interpretación de datos cuando realmente se debería estar generando valor en esto. Es así como es fundamental generar procesos que automaticen y apoyen el día a día, el trabajo del día a día de los geofísicos. De tal manera que nace lo que es el laboratorio de IA o el laboratorio de inteligencia artificial como un espacio dedicado para la investigación y aplicación de modelos de inteligencia artificial, modelos geoestadísticos, espaciales y espaciotemporales en la geofísica aérea. ¿Hacia dónde estamos apuntando? Con el laboratorio de inteligencia artificial lo que buscamos es asistir, y esto es muy importante. No buscamos reemplazar el trabajo de los geofísicos, sino lo que buscamos es asistir el día a día del trabajo de ellos. ¿Cómo lo hacemos? Principalmente combinando toda la eficiencia y el desarrollo de modelos computacionales, de modelos de inteligencia artificial, con el conocimiento experto de los geofísicos. De tal manera que ese conocimiento experto apoye y asiste, por un lado, al entrenamiento de nuestros modelos y esos resultados luego asisten al trabajo del día a día de ellos. Con esto lo que buscamos es que nuestros modelos entrenados capturen esas relaciones complejas o esos patrones o esas correlaciones espaciotemporales que a menudo se escapan del ojo humano al momento del que el geofísico está interpretando la información. El real valor de esto básicamente consiste en crear una sinergia entre el conocimiento experto de los geofísicos y el conocimiento o los modelos de inteligencia artificial que previamente hemos entrenado con esa gran cantidad de datos para generar interpretaciones mucho más precisas y optimizar esos procesos que hacemos en el día a día. ¿Cómo estamos trabajando actualmente? Primero partimos de una identificación de casos de uso. Esa identificación de casos de usos es básicamente, nos reunimos con los geofísicos, ellos nos explican en dónde podríamos nosotros poderlos apoyar y parte de necesidades tanto internas como necesidades de nuestros clientes. Luego de eso pasamos a un proceso de investigación detallada. Con esto estamos trabajando actualmente en cooperación con la Universidad de Stanford, en la cual nos ayudan en ese proceso de investigación y de encontrar qué modelos son los más apropiados para apoyar el día a día de los geofísicos. Luego de esto hacemos unas pruebas de concepto con los geofísicos, con el equipo de GIS y con el equipo de inteligencia artificial para poder validar estos modelos que hemos desarrollado, qué tan viables son al momento de aplicarlos. Luego de esto generamos soluciones que son altamente escalables y interoperables. Esto es muy importante, ya que nuestros modelos, más allá de ser modelos entrenados, juntamos lo que es la ingeniería de software para generar modelos que sean altamente escalables. Para finalmente generar lo que son soluciones de inteligencia artificial y que ayuden ese día a día del trabajo de los geofísicos. Algunos de nuestros casos de uso, el primero de ellos es el timeline leveling, en donde básicamente se detecta que los geofísicos gastan mucho tiempo en ese proceso de adquisición y corrección de los datos adquiridos, principalmente de los datos magnéticos. Al momento de hacer la interpolación, se revelan que hay unas discontinuidades espaciales que no tienen un sentido geológico. Para esto hemos desarrollado un modelo en el cual consiste en que ajusta los puntos adquiridos por el sensor magnético y luego mejora ese proceso de la interpolación espacial. Hemos logrado reducir el tiempo cerca de un 80 a un 85%. Y algo importante, y es básicamente lo que hablaba de las soluciones altamente escalables, y es que hemos desarrollado soluciones que tienen dos componentes. Un primer componente es esa parte de la interfaz geográfica que actúa como el frontend, que es el QGIS, y otra parte que son los servidores que actúa como componente del backend que tiene toda la lógica de nuestros modelos aplicados. Otro caso de uso es la delimitación automática de lo que son lineamientos geológicos. Como lo decía previamente, la idea es que los geofísicos se centren en detalles mucho más críticos del dato para generar más valor de estos. De tal manera que los geofísicos tardan mucho tiempo en esta delimitación automática de lo que es un lineamiento geológico. Para esto hemos entrenado una red neuronal capaz de automatizar y asistir, ¿cierto?, ese trabajo de la delimitación automática de los lineamientos geológicos, cosa que el geofísico se centre en corregir o mejorar nuestros resultados y no partir desde cero a la hora de hacer interpretación. Otro caso de uso es la compensación magnética, en donde, como decía previamente, con esa gran cantidad de vuelos que tenemos, lo que hacemos es entrenar unas redes neuronales capaces de corregir ese campo magnético generado por la aeronave para en últimas quedarnos con el campo magnético generado propio de la Tierra, ¿vale? Con esto también hemos generado unas mejoras considerables y nuestro modelo pues seguimos mejorándolo y pues la idea es llegar a resultados mucho más precisos. Un poco de nuestro equipo, como les comentaba, hemos tratado de integrar la inteligencia artificial con soluciones escalables a nivel de desarrollo de software. Entonces contamos con ingenieros de software, matemáticos, geofísicos, bueno, de diferentes campos del conocimiento que nos permiten poder generar estas soluciones altamente escalables e interoperables. Gracias.
And I'm sorry that not all of you speak Spanish, but the slides at least were in English. We'll have time for a chat later on during the coffee break. Just bear with us, we're running a little bit late, but I think all the presentations are worth the time that we are giving them. And if I can read well here, the next one is Terranigma. And okay, thank you very much.
Hi, everybody. Thank you for having me. I am Anna from Terranigma Solutions. We are a small startup from Aachen, Germany. And I want to start the presentation by tell a bit about us. We are coming from the University of Aachen, from the Computational Geosciences Institute. During his PhD, our co-founder, Miguel de la Varga, he developed his open source geological modeling, 3D geological modeling software, GEMPI, which is available for everybody, free to use. At some point, we decided that there was a potential to create a company around it, and we founded Terranigma in 2020. Our expertise is based on, as I said, 3D geological modeling. Also, our institute is one of the few institutes in the world that do science and understanding uncertainty quantifications. And for the past few years, we have been developing our own product, our own software for 3D geodata visualization and modeling. We started as a company with EIT Raw Materials funded project together with other partners, and we started developing liquid earth in that project. And when the project finished, we kept on developing our software. At the moment, Liquid Earth is on open access and free and early access, and everybody can just go on a website and try it. It can be used to visualize, collaborate, and present any kind of 3D geodata across platforms. You can gain deeper insights on your 3D data, and it can be, like I said, used on desktop computers or smartphones, tablets, but also on VR headsets. We also have a collaboration, platform collaboration that you can just go together with your colleagues into the same 3D space, and there is voice chat. You can use pointers, annotation, sketching, callouts, and all kinds of, And it's another use case, as you can use it for presenting your data to your customers. You can create very easily through the website, through the app, a QR code or a link, a deep link that you can just send over. Then the other person just gets the app and can just join you into the 3D space. But we don't want to just leave it here. So as I mentioned at the beginning, we have our own 3D geological modeling engine, which is open source, and we are working on integrating it into the Liquid Earth platform. This is a prototype that we have at the moment. The idea is that you can just put some points and some orientations, and you can create conceptual models on the go. We are also working on digitally bringing the field and the office together. Like, for example, in this case, making a scan of an outcrop and being able to access it from the office at the same time, or accessing, for example, a mine site when it's when the rock faces have been scanned, so the geologist doesn't have to go into the mine every time. And for the future, which is a bit on research and development coming from our institute in the University of Aachen, we want to include probabilistic machine learning methods for maximizing the value of information and making uncertainty quantification for geological models. Our roadmap, Liquid Earth 1, like I said, is already commercialized. You can already use it. And the rest of the things that we are working on are going to be coming in the next months or couple of years. And yeah, we are searching at the moment for pilot projects, users, and also European projects. So if anybody is interested in talking to us, just come visit. We have a booth at the Pavilion 3 in the conference, or just come talk to me later. Thank you very much.
Thank you very much, Anna, and thank you for saving us a lot of time. I also know that you have the car that you need to change the ticket. Yeah. So. But no, I think it is very interesting to hear about more data, more information, and also offering the possibility for a project is very hard. Yeah. Thanks. Okay, we are getting there, and save all your questions. I need my glasses for the next presentation because it's written so small. The next one is, again, a partner in one of our projects. We have Teradat, and again, we are very much in the exploration traceability field. So Teradat, anyone would like to come to? Here we go. I just need to, okay. Are you this one? Okay. But with us, the last three presentations.
Good morning, everyone. I am Jorge Acevedo from Teradat. And today I'm going to talk about how geophysics and monitoring can help the mining industry. We are a company that were founded in 2021, and we are part of a bigger company, which is Teradat UK, which is located in Cardiff. Our headquarters are located in Oviedo, in the north of Spain, and now we are working there for geoscientists. We collaborate with the Oviedo and the Potsdam universities, and since our establishment, we have won 2 European projects. The first one was Mind the Gap Smart Mining, and this October we have just started a new project, which is the Explorer, recognizing European potential from hosting deep land primary critical raw materials by combining new mineral models and advanced exploration and visualization techniques. Our main goals are to provide cutting-edge geophysical exploration and monitoring services for the mining industry, but we are also very committed with innovation and education, as these projects demonstrate, but also we have grants for undergraduate students in the University of Oviedo. This is our team, our General Director, Dr. Javier Olona. We are 3 geophysicists, Alejandro, Pablo, and myself. And we also collaborate with Dr. Andrés Olivar, who is now working in the University of Potsdam, and he's an expert in the innovative field of passive seismics. We apply several geophysical techniques, but we are mainly focused on the seismic methods. We can help mining industry with drawing geological maps. In mineral exploration, we can monitor tailing ponds, for example, to check their structural stability. We can help with engineering operations, and we can also assess natural hazards to enhance the safety in mines. Our latest services, the latest services that we are offering are seismic monitoring and also passive seismics for exploration. We are capable of deploying seismic arrays in the field to detect and locate earthquakes. And this is important because we can establish the seismicity baseline in any region where activities that may induce earthquakes are going to operate. And we can also monitor that seismicity to set up alarm systems to stop those activities if the seismicity rises above a certain threshold. Talking about the passive seismics, we have a nodal system, which is a great advance because these devices comprise all the elements of a traditional seismic station. For example, the geophones, the data loggers, the storage system, the communication system, but just in a small device, a very lightweight device with no cables. So the logistics becomes more simpler. These devices can register ambient noise, and this ambient noise can be cross-correlated to create tomographic maps, and then it can also be processed to obtain S-wave velocity models. And these models can help to detect mineralizations or geological features that are related to this mineralization. Now I will show you our first example, our first job within the Explore project. We deployed a line of 3,300 meters with 38 nodes, spaced 90 meters. And here you can see 2.5 hours of an ambient noise register. And there are some curious things that may be worth commenting. For example, you can see some nodes or some lines with more noise, and those were related to water pumps that were extracting water from all mines, from all galleries, from all mines there. There are also some spikes that form a line. Those spikes are related with trains circulating through rail tracks that cross the study area. And there is also interesting that that line have a break, and this break corresponds with the trains stopping in a train station that is located in the southern part of the study area. The final result, the final model is this one, and you can see how there are two different blocks. A southern block with lower velocities and a northern block with higher velocities, and that's related with the geology of the zone. The southern block has marls, while in the northern block there are limestones. There is also a low velocity corridor, which is related with the presence of a fault, and you can also see a high velocity line or corridor, which is related with the mineralization. And this is coherent with the geological model that were extracted from boreholes. So to conclude, we can say that geophysics can play an important role in enhancing the efficiency and precision of mineral exploration, it can also be used to improve the safety in mining operations. And these new services, seismic monitoring and passive seismics, can be used to monitor and to control operations that may induce earthquakes. And also passive seismics, ambient noise recordings, are useful to obtain high-resolution models with geological and mineral significance. Many thanks for your attention.
Very much, and thanks for the interesting presentation again. I can stress enough. Another project that we're involved in, actually we are leading Explore, so thanks to Taradat for introducing this project, which will start very soon. And we're moving to the last two presentations, and again I forgot presentation here, and we've got GMV.
So how is this working? Is this button? Yes. Which button is the one I should use? This one? Or?
Yeah, this one? No.
Okay. Yeah.
That one.
This one. Okay. Yeah. Thank you. So thank you very much, and good morning, everybody. Thank you for being still here with me. So my name is Almudena Sanchez. I'm responsible of our participation strategy in collaborative research projects. So happy to be with you and share some of our activities, especially in this industry. So in particular, we will talk right now on the remote sensing to support mining activities or mining industry. I will give you an overview of GMB, just for those that we do not know still the company. The remote sensing activities that can support mining activities on both exploration and sustainability. Some examples of our activities for mining industries, examples to support environmental security, ground stability as early warnings, and also preliminary results of one of the projects that are supporting this clustering event, the secure and sustainable supply of raw materials for EU industry S34I project. So, well, GMV is a global technological group. We have 40 years experience, so accumulated right now. We are a private company with a multinational footprint. We have presence in more than 10 countries, so 12 in total in the 5 continents, mainly with a European footprint. We are more than 3,000 people, and in the space sector, which is our root, we are the 6th largest industrial group in this sector. So you can see from the figure, we are a very solid partner from the financial point of view. How remote sensing can support your activities, either mining company or engineering company supporting the mining industry? Well, Earth observation-based added value services or solutions can support the different phases of a mining project. So starting from exploration, passing through feasibility study, mining planning, mining operation, and mining closure, with some examples that I am giving you here in non-exhaustive mode. For instance, the characterization of the landscape using multi-temporal analysis as well, so you can follow in the time how evolution occur. to identify minerals in exploration phase, for instance, using different kind of images, multispectral, hyperspectral missions, and new satellites are there for that. And also other examples are to delimitate hydrological network and monitor subsidence in an, let's say, in an independent manner. Among the benefits, well, you can study large areas, so you can map those areas, avoiding or saving potential hazards to deploying people on site. You can produce maps of interest for different purposes, environmental aspects, habitat fragmentation, also to get proof of compliance with regulation. Very interesting as well, to support the process of social license to operate, especially important in early phases. And, well, other examples of benefits to deliver early warning phase to subsidence risks, environmental impacts, and others. So, just as examples. So, if you're running a mining project, which could be the good reasons to use this kind of solutions and technical methods. Well, I have bring with you some top examples, 8 in total. So starting with the first set, enhanced resource mapping, we have already mentioned, to elaborate detailed and accurate mapping of deposits. Also from environmental monitoring, we have also commented, monitoring environmental impacts in both land, water degradation, so ensuring sustainability mining practices. Also risk assessment, so services that can monitor geological hazards and help mitigate risk with mining activities. Regarding infrastructure planning, can support on the mining operations, so planning the development of infrastructure such as roads, power lines, etc. The second set of good top reasons is cost-effective data collection. So you can get information in a very effective manner, and you can make really extensive surveys, lowering the cost of that process. Also the regulatory compliance, those methods or those services gives you independent proofs of or evidences to adherence to legal standards. Also commented, community engagement. Those services provide evidences of the mining activities, so we can foster the transparency and trust, and also climate change adaptation. So climate change means that, for instance, water availability or extreme weather affects the operation, and this can be tackled. Some examples, I give you a couple of good examples. So environmental security that can be used during mining operation and also closure and post-closure. So you can see the temporal evolution of the mine, and due to minerals contamination, that's a mining in Romania using Landsat and Sentinel-2. That's another good example on ground monitoring using, in this case, Sentinel-1. You can see the area of Philippines for detecting mining specific subsidences patterns. And last one is preliminary results for this project, that's 3-4i. And in here we are producing super resolution images on radar Sentinel-1 and also Cosmo SkyMet data, so that we improve accuracy 4 times. And this is using free data and can be compared with the resolution of very high resolution images that are private and more costly. This is a second example in another mine, also in Finland, where super resolution is used and normalized difference coherence index is performed, so that the coherence can serve to monitor the environment, the limits, and can support in the regulation compliance as well. So that's all. Those are just few examples, so not exhaustive. And yeah, for sure, if you have questions or doubts, we'll be very happy to answer. Thank you.
Thank you very much for a very exhaustive presentation. It was very well received. And no, perfect timing, perfect timing. And the next one and last one presentation is from Peter from LC Innovation Consultants. And put your presentation on, and then
good morning, everybody. I am a kind of odd person here because I am neither a geo guy nor an exploration guy, but I am an exploitation guy. So the reason why I am here that in Horizon projects, starting with FP7, exploitation was something which was there a little bit. Then in Horizon 2020, exploitation became important, and now in Horizon Europe, exploitation is a key factor both in the project evaluation, project proposal evaluation, as well as during the implementation of the projects, and also the expectation of the Commission, as well as of myself as a European taxpayer, because I am the investor of these projects. So my company provides exploitation services to European projects. I don't want to go too much into details why this impact issue is important. What we provide as an exploitation partner is knowledge management, which means things around IP, because the results of your projects, especially the key exploitable results of your projects, are intellectual properties. And there are many things which should be clarified regarding the intellectual properties, issues like what are the background IPs, which means that IPs generated prior to the project, freedom to operate. Are you sure that you are not infringing any other existing patents? Not always. What is your protection strategy? Do you want to register your IP or you don't want to? Or is it recommended to do so or recommended not to do so? There are many, many cases. And who is the owner? Especially as they are collaborative projects, there are results when we have shared ownerships. 2 or more owners of an intellectual property. That should be also clarified. Exploitation. During the project implementation, you reach TRL 6, 7, usually not higher than that. So there are still a couple of steps to go to TRL 9, which means ready to market. And what will be your roadmap to reach that ready to market stage? What will be your business model? What will be your business plan? And also risk analysis. Recently, we were requested also to provide communication and dissemination, but that is, that we can do it, but that is not our core business. I mean, in a couple of projects we do it, and we have experts to do that. But also monitoring innovation, especially in innovation actions. Market analysis is a very important part. We do market analysis. We have special people understanding market analysis, as well as specialists understanding the professional content. And we always do it with 2 people. And if it is needed, techno-economical feasibility study, but that goes normally in the LCC-LCA services, which is provided by other companies. So our references, we have been involved in 12 projects. 2 of them are related to the topic of the current event. Yesterday in the morning session I presented DeepBeat, which is a very new project started in October. We are a partner for knowledge management, exploitation, communication and dissemination. And in the afternoon session, NeoCycle, which is also that started in September, we are also a responsible partner for all these tasks. So there where we have been a partner, and we also provided external exploitation services for more than 80 projects in the last years. So we have some understanding what is expected by the European Commission regarding exploitation. So just a few more words. We have other activities beyond the partnership in Horizon projects. We also do technology transfer and working with startups and startup ecosystems, and trainings on commercialization. So all these other activities feed into the Horizon activities, because if we understand from a commercial environment what it means to do technology transfer, what it means business development, what it means establishing a startup or a spin-off company, that helps a lot with the project implementation. Our experts, we have 10 plus experts. Our senior experts, they have a very solid background in sciences, as well as they have a very solid understanding of business. I myself, I used to be a researcher as well. Once upon a time in historical times back in the 80s, and I was, by education, I'm a physicist, but I was working more as a material researcher. I received the Young Scientist Award of the European Material Research Society back in 1988, so long time ago. I mean, even some young ladies were not even born at that time. So, if you want to plan your new project and you need somebody who understands the impact section, then we are there. What we offer, we develop chapter 2.2, which is usually the most painful part of the project proposal, because engineers, scientists, they are ready to develop chapter 1, excellence. Chapter 2.1 is okay, but chapter 2.2, then most people just say, oh, no. So there we are. We do that. We also develop the work package for non-technical tasks, and we are ready to be a work package leader. I hope that we can partner in the future. Thank you very much.
Thank you very much, Peter. That was an excellent presentation to close the session, because we have talked about all the different technical elements that we would like to develop in a project, but of course we need also to put it on paper and make sure that we write a successful proposal. So first of all, I have to say goodbye to our colleagues that were following us on streaming, on the internet, because the next part of the day will be just here physically, and this is where we get productive. This is where we sit down, we talk about project proposal, project ideas, something that can become a successful funded project in the future. But first of all, I would like to say thanks also to the ISMC, Iberian Sustainable Mining Cluster, colleagues that have prepared this event and they put a lot of effort to make sure that all the logistics go well. I would like also to say thanks again to all the project partners that we've got here. Peter is one of them, and all the others that have been mentioned. I would like to say thanks to the projects that we've got here, S34I, TerraVision and Muddy Trace, that have supported the project, and we've got a lot of partners from these projects here today. And before you go for coffee, the coffee will be served upstairs, and you go and mingle, caffeinate yourself, get your brains going again, start talking, start the conversation, because when we come back, we want you to sit down in 3 or 4 different working tables to start discussing the initial seeds for project proposals. So be ready for that. Before we go for coffee, I would like you to put your hands together for all the speakers that we had today that did a fantastic job to prepare the presentations, to bring the content here, and to get this very stimulating debate. So please put your hands together for all the speakers today.